Okay, so we're going to talk today about slow flight.
All right.
And
Sure.
all right, and so first of all, why would we want to fly slow? Because there's a lot of negatives about it, right? You don't get very far very fast, and it's inefficient. You're getting close to being at stall. The engine doesn't like it. There isn't enough cooling, as much cooling airflow as. So why? Well, and the answer is, well, we have to, right? There are times when we have to fly slow, and particularly when we're coming in for a landing, and or take off. So those are times where we have to be slow, and we have to be good at it. And there's some interesting things that go on during slow flight that you need to take into account. So we talked on a previous lesson about drag, and just to remind you, so if this is airspeed and total and drag here, and remember there's two types of drag. So your parasite drag increases with the square of airspeed, and then induced drag is the opposite. It comes down with airspeed, and so now the total looks something like this. There's a bucket to it, and there's a minimum drag speed. All of this is assuming we're flying at 1G, straight and level. Now, so this is drag. Okay, well, so now think about it in terms of thrust. We want to fly along at 1G, straight ahead. How much thrust do we have? Well, the four forces, right? We've got to have enough thrust to offset that drag. And so the thrust curve, the required thrust curve looks kind of like that in terms of speed, and here's thrust. Okay, now how about the engine? How much does it put out? Your engine thrust, actually, the amount of thrust it can put out varies a little bit, and it depends a constant speed prop versus a fixed pitch prop. But generally, it'll look something like this. It's not flat with airspeed, but it's reasonably flat. So here is available thrust, and here is required down here. Okay, so now I guess think about it in terms of we're flying along somewhere here, and we. And we're at a nice steady airspeed here. If we put some more throttle in, we get more thrust. That brings us up, and the airplane just naturally speeds up to whatever thrust setting you have that matches the drag. Okay, so on this, so pick a spot here and imagine what happens. We're flying along with the throttle we're not full throttle, we're in cruise flight, for instance, and something, maybe a little gust of wind bumps us up maybe just a little bit higher speed than we were at. So we bounce up here just a little ways. Well, what happens here? We've got now a lot more drag than what thrust we're putting out, and so naturally we are pushed back. There's more drag, so it pushes us back to where we were in terms of speed. And same thing happens if we happen to maybe just pull back just a little bit, or there's a gust or something, we get a little bit slow. Well, now we've got this is our thrust setting here, and we've got a lot more thrust than we have drag, and so we speed back up. So this is stable. We're at a nice stable place here. Push the throttle in a little bit more, we just naturally climb up there and don't have to think about it really. Now, all of that is on the right side of the bottom of this bucket here. On the left side, it's just the opposite situation. So imagine, go through that scenario again. We're flying along, and now a little bit of a gust hits
If you
us.
look that way, then we can see it.
A little bit of a gust hits us, for instance, and we slow a little bit. Well, now we've slowed down a little bit. The required thrust is way up here, and so we are now we've slowed down a little bit, now we're going to start slowing down a lot, right? There's no tendency to put us back where we were. It's just the opposite. And we kind of talked about the marble on top of a hill. That's the situation. It's really unstable. Same thing if you happen to speed up just a little bit, and a gust or whatever, and well, now the thrust required is actually lower, and so we're going to now motor away from there from that speed. So this whole area here has this situation of being basically unstable in terms of speed, and it's called the area of reverse command. And another term for it is behind the power curve. Now, what does that mean, area of reverse command? Well, it's just that if you, for instance, pull up a little bit to try to maintain your altitude, which is not the way we maintain altitude in here, but if you did, you slow down, and now suddenly the airplane does just probably the opposite of what you wanted to do. It heads south, and so you have to be actively controlling your airspeed, and especially the steeper this curve gets, the more unstable that is, and the more it'll be apparent once you get there. And so in this region, it's especially true that we control altitude with thrust, or the throttle. So and our speed with the elevator. So we'll be practicing and learning to do this well, and fly around not only straight and level but turns and maintain a given altitude. And it's very important. I mean, that is the whole a bulk of the skill, is to learn to trust that that's how you do it. You maintain your altitude. If you start getting a little bit low, resist the temptation to try to pull back and do it. Your elevator, your yoke, that's controlling airspeed, and the throttle is controlling your altitude.
What about the region of normal command? How would you describe that?
Yeah, well, so that has this stable aspect to it, and so because we fly, just a second, because we're in that region so much, it can make you a little bit lazy if you're not careful, because you can come to think of it just the opposite of saying, hey, I'll just put in a certain amount of power and off we go, and you can, in a way, get away with it a little bit in terms of holding altitude with elevator, and maybe there's nothing wrong with that, but much better if you do this, if you treat altitude with thrust, speed with elevator throughout the whole envelope. It works just fine. Like I say, you can get a little bit lazy in this region and get away with it.
What's the reverse part of the region of reverse command? What's it reversing?
Well, as you again, let's see, and probably here's the first scenario you'll probably get into when you get into this. You're going to be having a little trouble keeping altitude. Okay, so you're 20 feet low. Okay, you want to pull back, and then exactly the opposite happens for what you wanted to happen. That's going to slow you down a lot more. You're going to not only slow down but lose altitude. And so, yeah, I think that's where the name came from originally. People recognize that, wow, you kind of get the exact opposite of what you wanted.
Yeah, I don't know, I think of it as in the region of, and you can tell me if you think this makes sense, as an explanation, in the region of normal command, to fly slower, we'll reduce power, right? In the region of reverse command, to fly slower, again, slower than minimum drag speed, we will add power, and that kind of, I think, helps people get, okay, I get the reverse part of it now. But also, you might want to just also explain what's happening, because you drew the drag curve. So what we have is a dramatic increase in induced drag in the region of reverse command, which is why we need power to offset all that induced drag. So why don't you just kind of explain that?
Okay, all right. Yeah, so what's happening here is in the area region of normal command, you add power, and that increases your speed, and and your speed increases, and so your drag increases, and you come to a nice equilibrium again. On the area of reverse command, reducing, so in order to go faster, you actually have to sorry, let me put it another way. To go slower, you actually takes more thrust. And the whole reason is because back to this drag curve, this induced drag is increasing dramatically as you go slower. So to get back slower, your drag is increasing. You actually have to increase power to do that and maintain altitude.
That's great. I think that's an explanation of, in a way, of why you drew the drag curve.
Yeah.
Induced drag goes up dramatically in the region of reverse command. Okay, keep going.
Okay. Well, so let's see. Now, we talked about the basic control in that region. Now, as you get slow, what else happens? You know, the left turn tendency increases a lot, and so in slow flight, that's a big part of it, is to recognize that if you're getting uncoordinated, you can anticipate that there's going to be a lot of corkscrew effect and torque and P factor, and just anticipate that you're going to need to be on the rudder for that, and stay coordinated, especially since we're now going to be fairly close to the stall. Also anticipate the controls are going to be, you might call them mushy, or at a nice cruise speed, you almost just have to think about turning the yoke a little bit, and you start a bank, and at slow speeds, it takes quite a bit of aileron deflection, elevator, rudder to move the airplane. So you can think of them as mushy or sloppy or something, but you'll just need more control deflection than you are at high speed. Okay, so let's see, how will we do this in practice then? So we will, now, absolute minimum of 1,500 feet, but I'd say let's, for safety, let's go into it at, let's go into it at 3,000 feet AGL. And then, so of course you're going to want to, we're going to be in this region of reverse command. So now what is this speed? Well, you won't, this minimum drag speed, you're not going to find that in the POH. Might be a fun project to try to figure out exactly what it is, but we don't know. But it's certainly something below maneuvering speed, but below the best L over D even, and so it's probably in the order of 70 knots or 65 or something like that. So what we'll do is bring the power back. We'll of course set up, clear the area, and get the airplane configured however specified. So we can do this with flaps down or flaps up. And then pull the power back to, let's make it 12 inches, and hold altitude. So you'll need to add some trim as we slow down and slow down. And so then as you come into, as you get closer to in the high 50 knot range, bring the power in smoothly, and then absolutely be thinking this. That's the main thing. Control your altitude with the thrust and the speed with the elevator. And so with the elevator, we're going to reduce our speed gradually. Let's bring it down fairly slowly, 55, and about sometime around the time we get to 50 or so, we'll probably hear the stall horn. And what we want is, and we're holding our altitude with the thrust lever, and we're controlling speed with the elevator. Once we touch that stall horn, we'll just speed up just a couple knots, and we want to stay just between that first indication of stall and about 5 knots above that. And then in that configuration, we'll have, because we're way up here, high drag, you'll be probably surprised at how much thrust it takes to do that. And then we'll fly around, and maintaining altitude, maybe we'll try to climb a little bit, and so if I say, okay, let's climb 100 feet, well, altitude is with thrust, so the thrust comes in and you're maintaining the speed with the elevator. And same thing if we try to descend or do some shallow turns. Now, why would we do shallow turns and not steep ones? We are operating up here fairly close to the top of the lift curve, up close to stall. If we add load factor, so a steep turn or an abrupt maneuver, we're likely to get us over the top of that and into a stall. So any turns we make will be very shallow. And then let's see, once we're done with that, how do we come out? Well, we've got to get back up in speed, and so typically that'll be, we'll anticipate we're going to need cruise thrust, so we'll go to that, and we'll just power up, back up to cruise and configure for it.
Oh, okay. You want to explain, maybe we'll back up just a little bit, that you kind of got there, but you said we'll increase speed a couple of knots. You could say, the book says 3 to 5, but that speed then, that additional 3 to 5 is our new 0 when we start to talk about standards. So that's the speed that we're going to try to maintain, is that speed, the one that was plus 5, 3 to 5, plus for a private pilot, 10 from that speed. You want to kind of clearly explain that. And if you're a commercial pilot, it's going to be plus 5 from that additional 3 to 5 knot speed.
Yeah, right. And
that's from the SAFO.
Yeah, and there are heading and bank limits as well for our, thresholds for the standards.
Yeah, when it comes to standards, but I think at this point, when you're talking about achieving slow flight, the achieving of slow flight is going to be stall plus 5, achieving a 0, and then it's plus 10 or plus 5 if for a commercial pilot from there. And that's the region we're trying to fly in.
Yeah, okay.
So just explain that.
Okay.
And we'll just add it all back.
All right. So what we'll do is...
and I would I'll back up a bit. So for a student pilot, if you say we can do it clean, we can do it flaps, just explain, I would say, one configuration and how we get into it. So let's say we'll do it flaps. So as we just talk about how it actually occurs, we're going to bring back the power. We'll get into flap range, put first 10 degrees, flaps. Nose is going to tend to want to come up. We're going to have to trim it. Just kind of give the running commentary about how we eventually arrive at the stall horn.
Okay. All right. Okay, so what we'll do to get into it is we'll bring the power well back, and we'll need to get the power way back to get into this command. So we'll go, let's pick 12 inches or so to start with. Now, as we get into, into flap range, we'll get 10 degrees of flaps in to start with, and you'll notice the pitch change that you have to, anticipate. When we're in the white, we'll bring gradually the rest of our flaps in, 20, 30, we'll go to 40 flaps, and then as we settle into lower and lower speeds, the thrust, the drag's going to be increasing a lot, and you'll be surprised at how much thrust we need, but the power needs to come in accordingly. And be thinking about this, and remember that now you're absolutely controlling your altitude with the thrust and the speed with the elevator. So we'll just slowly reduce speed down to high 50s, and gradually get down to low 50s, and somewhere around 50 or so, maybe even a little bit lower, you hear the stall horn. Now what we want to do is find a spot that's about 5 knots higher than that. So you'll be watching, keeping our altitude, watching our speed. We touch, let's say it happens at 50, so now we'll just remember we're going to control speed with the elevator. We'll speed up a little bit to about 5 knots higher than that, and then note that speed. That is the speed that we're going to be flying these slow flight maneuvers at, and we don't want to get below that. We can get just a few knots above that is fine, and there are standards, no more than 5 knots for commercial or 10 above that. That'll be our speed to fly, and we're controlling that speed with the elevator and controlling our altitude with throttle.
Okay. Yeah.
Now, let's see, some common mistakes. Well, this might maybe top the list of common mistakes is forgetting about this and trying to control your altitude with the elevator. And if you do that, I think you'll notice right away how poorly that works. It really is not the right way to do it, and you'll probably find out right away why. Allowing us to stall, getting so slow that we actually stall, that's certainly a mistake that can be made. And staying coordinated. Remember, all this power, we're going to have a lot of left turning tendencies, and so stay coordinated.
Okay.
All right.
Okay. Now what?
Well, standards. Okay,
Standards.
So yeah. So if I so these maneuvers. So the idea is we'll probably not just go straight and level. I'll ask you to make a left turn or a right turn. When we are going straight and level, I want you to, as we go into it, pick a heading, pick a reference point out in the distance, and you'll be noticing your directional gyro as well. But stay on that heading. So as we're straight and level, we want to stay on that heading, and the standards are plus or minus 10 degrees on that. I'll ask you to make some turns at a bank angle, and these will be shallow bank angles, but the bank angle, the standard, is plus or minus 10 degrees from that. So if I ask you to just give us a 30-degree bank, then plus or minus 10 on that 30. That's for private, 5 degrees plus or minus for commercial. And as far as altitude goes, the standards, which maybe challenging at first, but you'll get the hang of it. But 100 plus or minus 100 feet, we want to maintain for a private pilot, and plus or minus 50 for commercial.